All right, now it's time to test the water. The things that we're going to test for in this session here is going to be our pH, our ammonia, our nitrite, and our nitrate. We're going to do that mainly with the API Freshwater Master Kit, which is right here. And this is the card that comes with that, so you can see your readings. Okay. We're also going to test our pH with another method, which is this, which is an electronic pH meter. It's right here. This one here, I only paid $12 for this one on Amazon. So this is the meter itself, it has a cap, and this is the probe that goes into the water. And then when we're testing pH, I'll actually go over this and why I prefer this one more so than the chemical one. Okay. But the other things on the table here, this is just a test tube rack that I kind of put together myself. And I also have this one here if we want to test more samples. So we have 4 test tubes here. Now each API Freshwater kit is going to come with 4 test tubes. But with this rack here, you can do 6 different tests. Or if you had students in 6 groups, you will break them up and have each group they can use 1 test block. Okay, another method, if you want to use that one, is the strips. These right here are the pH strips. They come in these little tubes like this, and the paper looks like this. It's one little small piece of paper that you dip into your solution, and it's going to turn a certain color. Then you use the color chart to find out what your pH is. Okay. All right. And over here is the actual water sample that we took from the tank. Okay. So we're going to go ahead and start with the pH. First, I'm going to start with the pH meter. So with this, you just take the cap off. I'm going to grab our sample. We turn it on, and you'll see the number comes up. But all we have to do with this is just put it in the water and swirl it around. Okay. We swirl it around. The numbers are starting to move. They started around 7 point something, but they're going down. We're currently at 6.3, 6.2. I'll see if I can get this in the shot here. We're at 6.2, so we're on the acidic side. Now the pH scale goes from 0 to 14. And it starts on the acidic side, on the low side. Once it's 7, that's neutral, and then anything above 7 is going to be basic. Okay, and with this, we just swirl it around until the number stops fluctuating. And right now we're down to 6.0. Okay, and it looks like it's slowing down. And I think it stopped at 6. Okay, so we'll take this out. Turn the meter back off. And normally I would dab this with a paper towel before I put the cap on, but for now I'm just going to put it on to move it out of the way. I have these these disposable pipettes. You can buy these from offline, but these are disposable. And so when you use it once, you don't have to wash this out. You can just throw it in the trash. If you can buy these in a huge bag. I just have a few here, but you can buy these so when your students are getting water samples, they don't use a dirty pipette to contaminate the sample. Okay. So with these test tubes here, there's a line, and that line tells you that that's 5 milliliters of water. It's 5 milliliters. Okay. So we fill this up to the 5 milliliter mark. Okay, once we have 5 milliliters of water, we go over to our kit and we pull out the bottle for pH. And that is that bottle right there. Okay. Now for this one here, it says add 3 drops. Okay. So what I do is hold my test tube. I turn this vertically. 1, 2, 3, and I stop. I'm going to cap it. and I'm gonna mix it up. Okay, shake it for a little while. Now you have to wait 5 minutes for the color to fully develop. And so I'm just gonna set this to the side and we're gonna wait, and we're just gonna move on to the next test. The next test we're gonna test for is going to be ammonia. Ammonia have 2 bottles. Okay, we have a bottle number 1 and a bottle 2, and they both require 8 drops. So I'm gonna go ahead and grab my 5 milliliters of water. Test tube 1, I need 8 drops. One, 2, 3, 4, 5, 6, 7, 8. You also want to be careful. When I have 2 bottles, I make sure I cap one before I cap the other one because I don't want to mix the tops up. And then I'm going to do 8 drops of the second one solution here. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to cap this one here. I'm going to put the top on, and again, I'm just going to mix it up. And put it to the side. The third one is going to be our nitrite. I need more water. Nitrite here, it calls for 5 drops. Nitrite. So we'll give it 5 drops. 1, 2, 3, 4, 5. We shake, shake, shake to get everything mixed up. And we put it to the side. On this last one here, this one you're going to do something a little bit different than you did with the first one. So again, with the nitrate, we have 1, we have 2. Okay. So the first one, these require 10 drops. 10 drops. So let me get my sample. 5 milliliters. Okay, with the first bottle, you go ahead and put the 10 drops in. And let me show you this bottle. 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I cap it back up. This second bottle has to be shaken. We have to shake this for at least 30 seconds because there's a suspension of chemicals in here, and if the kit settles, those chemicals can settle to the bottom. So we have to mix this up for 30 seconds to get everything mixed again. And I just tap it on my hand. Okay, it's been about maybe 10 seconds now, so we'll give it another 20 more seconds. Okay, that's been about 20 seconds. Okay, so we stop, we open it up, And we're going to add 10 drops to the test tube. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. We're going to cap this here. The second thing with nitrate is that you have to, after you have everything in the test tube, you have to mix this for a full 60 seconds, for 1 full minute. And the reason why, and it's going to start turning colors while you're shaking it. You can probably see that now, it's starting to turn colors. But you have to do that so everything is mixed and you get an accurate reading. If you don't mix bottle number 2 before you add it to the water after adding the 10 drops from bottle 1, or if you don't shake it a full minute after you add the 10 drops from bottle 2, you might get an inaccurate reading. And so we don't want to do that. We want to have good numbers so we can monitor and manage the system as well as possible. So we just follow those instructions. It's important to teach our students how to follow the correct instructions, so when they start creating their own experiments and writing their own reports, that they put those instructions in there and they follow instructions, and they can write good instructions when they do their own. Okay, you can see it's still turning colors. Okay, and we just keep shaking. I'm kind of counting in my head. Normally I would have a little stopwatch out or have my cell phone out with my stopwatch running so I can see that minute go past, or that 30 seconds. For the 30 seconds, sometimes I tap my hand 1, 2, 3, 4, 5, 6, 7, 8, all the way to 30 to kind of give me a cadence. But that's been about a minute. So I'm going to stop and now add this with the rest. And that nitrate is the only one where you have to do all of the shaking. Okay. All right. So now this again is the card that we're going to read from. So what we do is we grab our pH. Now pH here told us it was 6.0. And what we do is we just match it up. And I hope it shows up there on the camera. But you match it up. So you match it up to the light. I'm going to hold it up, and it looks like it's very close. Yeah, it's closest to the 6.0 reading. Okay, and I hope I can get that on camera. Good. If not, then that color is coming out to this color here, 6.0. Now, the reason why I like to use the electronic meter is because pH is a logarithmic. So what that means is when you go from 5.0 to 6.0 or 6.0 to 7.0, 6.0 is 10 times more acidic than 7.0. So it's a huge jump to go from 6.0 to 7.0, or even with aquaponics altogether. Your system, if you jump from 6.0 to 6.4, that's 4 times more basic. So when you go that huge swings like that, the system doesn't like that. It stresses the fish, it stresses the plants, and it also stresses the beneficial bacteria, and we don't want to do that. So with this card here, it goes from 6.0 to 6.4, and I don't know where it is in between there. It could give me, I might think it's 6.4. If it's somewhere in the middle, I might think it's 6.2, but I want to know that. And then it jumps to 6.6, and then 6.8 and 7.0. So I want to know exactly what my pH is so I can better manage the system. And with this here, it gives you an idea, but it doesn't give you the exact number like a pH meter. Okay. And again, this is a very cheap one. You can get some that's much more expensive than $12. But for what I was doing, this worked well for me. Okay, so now if the pH is too high, well, actually, let me finish up the numbers here. Let's go to ammonia. Okay, so ammonia, I'm looking at, and we want ammonia in a perfect world, it will be 0. So it will be yellow. This color is yellow. We will want this solution to be yellow. It's not. Okay, so I know I have some ammonia built up there, and it's looking like it's about 0.5 ppm, and ppm stands for parts per million. So this is about 0.5. I don't want it to get any higher than 0.5. That's getting into the dangerous zone there. And again, a perfect world, I want it to be 0 because I want all of my beneficial bacteria to be oxidizing that ammonia as the fish or the snails or whatever's in your system is releasing that ammonia to oxidize it to 0. Now we go to nitrite. Again, nitrite is more dangerous than ammonia. So you want that to be 0. So we want that to be this teal looking color, and it's not teal. Here I'm looking at, looks like it's 0.25 ppm. 0.25. That is bad for the fish. It will kill the fish. It is toxic, and we want all of that to stay at 0. Now the nitrate, this is the plant food. This is what the plants absorb as plant food. And this is very high. We generally don't want it to be too high because that means we don't have enough plants in the system that's taking up that nitrate to remove it from the system. Here I am at the edge of the chart here. This goes up to 160 ppm. Okay, so that's only a fish tank with a few plants in there, and I hadn't changed that water in a while, so that's why this is at 160 ppm. 160 ppm is not going to kill the fish. It's not going to hurt the fish. In my previous aquaponics system, I didn't have enough plants to take out all of the nitrates, so it was around between 80 and 160 ppm. It doesn't hurt the fish, but we want to make sure that we're getting as much of it out. And that way we know that the bacteria is working. So this is the water testing. Again, there's some more things that we can test, like dissolved oxygen. We can test CO2, the carbon dioxide. We can test iron. We can test electrical conductivity. So a few other things, parameters that we can test in the water, but this will get you started for your basic aquaponics system in your classroom. Oh, one other thing is if the pH is too high, let's say it's 8 or 9 and you need to bring it down, we can use this right here. Another API product is called pH down. And if it's too low, let's say it gets down to 5.0, gets way down, it's way too acidic for your system, you can use this product to bring it up, and that's pH up. Okay. Last thing I want to talk about in this little clip is this product called Prime. This right here, if you're going to switch, if you're doing a water change and you don't have time to bubble the water to get all of your chlorine out of it, then you can use this here. This right here, it treats 5 milliliters, treats up to 50 gallons of water. And so you can measure it with the cap, or you can use one of these pipettes. These here go up to 3 milliliters. So if you put enough of this chemical up to this line here at the very top, that's 3 milliliters, that will handle 30 gallons of water. Okay? And what it does is it dechlorinates the water, removes the chlorine and chloramine, it detoxifies ammonia, nitrite, and nitrate, and it also provides a slime coat for the fish. And so if you add this to the water, you can add the fish in immediately, and you can you don't have to worry about the chlorine burning their gills, or if you know you have nitrites in the water or a lot of ammonia. This handles that temporarily while you add the fish in and can oxygenate that water to remove the chlorine, etc. Okay. I also have this little cleaner here. This cleaner is just a barbecue skewer with a piece of foam attached to the top, because this kit does not come with a way to clean these test tubes. And I want to make sure that they're clean each and every time I use them. So I just put soap in here, swirl this around, make sure I get the top, clean them, and let them dry before I use them the next time. All right.